My talk. One second. Thank you very much for coming to my talk today, Backdooring with Metadata. So a little bit about myself. I've been in the security industry for well over 15 years doing research. Recently, 4 years ago, I've co-founded a company called SafeBridge. And I've presented and still presenting in different conferences about different original security research. This is one of those. Feel free to hit my homepage, see my previous works, code examples. I'm sharing the most I can to, again, keep and educate and help spread the knowledge. With that being said, before diving into how you actually backdoor with metadata, let's talk a little bit about the problem that we're aiming to solve here, right? So the problem perspective that I'm going to be speaking of today would be from the adversary standpoint of view. So imagine that you're doing a red team engagement or a pen test engagement, one of those ethical hacking engagements that you may do. So you've owned the machine, you pop the shell, now you want to kind of move in your tools. And for the sake of this example, I'll be addressing it as a Userland backdoor, right? Whatever it may be, you want to bring on into that machine so you can feather pivots, so you can do what is it that you want to do. Let's talk about some failure points that can happen at this stage. So first and foremost, the act of trying to download that particular sample of malware backdoor tool may trigger an array of different network controllers, right? The act of the downloading can go through a gateway of the customer prospect, and then security solutions like sandboxing or content filtering may pick it up. We can see that even transferring the sample within the network, so if it's not your first station at the network, it's your second or third, even internally passing it between segment to segment, we still can encounter controllers like sandbox and network IPS. And then even the mere act of that computer trying to use the network may be an anomaly if there is a user behavior analytics on that machine, and that is action that has never done before, it can trigger alert. So that's the first failure point that we will address today. The second failure point is obviously once you transfer it over the wire, it comes to a point where you have to drop it into the disk. And dropping it into the disk, again, we meet a different type of security controllers that may pose a challenge to us, right? So saving the backdoor, again, the malware backdoor tool into the workstation, the endpoint, it may already have a reputation associated with it. So the sheer act of saving it to the hard drive may end up raising a flag. And then again, saving it into the hard drive may trigger other security solutions to further examine that piece of software, and then it can come back again saying this machine has been hacked. And last but not least, actually running that sample, that whatever backdoor malware on that machine, also we face another type of security controls that can create an alert. Of course, the binary that will be used most of the time will not be signed. And again, with the whitelisting application approach, that can be a challenge. And then even if we're not whitelisted on the machine, even there's not whitelisting solutions, again, running it may call for other process to look at that and say, hey, we never saw that before. Interestingly enough, let's examine what this process do, and that can come up as a flag. So these three typical issues, downloading, saving, and running, that occur after you post-exploit a machine could become a trigger that you want to avoid. Again, from the pen testing red team constellation right here. And that's even without getting into an IT issues that you may end up running to. So anything from connectivity issues, it's like, hey, I need my connection to download that file, all the way to you may be engaged in some kind of an embedded device, pen testing, or an IoT where there is constraints, and whatever backdoor that you want to bring for the purpose of the engagement may not be able even to fit into this device. So if we recognize the problems, let's start exploring how we can solve it, or what are the workarounds that can we use to bypass these restrictions. And in order to understand the ability to backdoor with the metadata, I'll break the concept into twofold. The first is what I call the BACE, which is the concept of binaries that allow you to run arbitrary code execution. And the second element will be addressing how you can actually then turn them into a backdoor. So beginning with the fundamental basic concept. So every one of you that ever touched a Linux or Unix box end up learning a bunch of very simple commands to admin that machine. Surely you all learn to use the command find. Command find is a very basic, very primitive one. It allows you to search for files on that computer, and depending on the parameters it could be, you can set up the destination folder, the source folder. There's basically a lot of options that involve with it, but again, it's an everyday application introduced at the very earliest day of Unix, the AT&T version 1, and here's this very kind of a benign example of how you can just search for all the GIF files that you have on your computer. Nothing out of the ordinary. However, if you put close attention into the find, and as I mentioned, find has a lot of interesting command lines, you will see that one of the command lines that find actually provides, it's the dash exec. So the dash exec is basically a feature flag that allow you to run a command, any arbitrary command that you would like, upon finding a file. As you can imagine, this could be very useful from an IT administration point of view, where you want to search for files and then change their name, change their permission, delete them. You can basically associate an action with each item. But is it all you can really do? And in this example, which I'll quickly run for the proof of burden here to show that it's working, I decided to run the command ID. So the command ID has nothing to do with either of these finding the files. It's actually a standalone command. It doesn't pipe anything into it, but it will eventually run. And there is nothing special about the command ID here that I've used. And as you will see further down the presentation, there will be other commands that I will use that will be more useful to me as the adversary. But in this case, this is just an off-the-bat example. So let's recreate this very easy example. So as you can see, I first started by creating some benign file called temp foobar, or foobar in my temp directory, and then I invoke find on the temp directory, ask him to search for a file called foobar, which of course he found, and then as a result I asked him to run the command ID, which he did, and that's the output. Nothing fancy here, I'll just get rid of that file. And so when I first kind of started thinking about that and looking for that kind of anomaly, take a second to get back. When I first thought about it, I thought to myself, could this be the only case? Could this be the only binary that has this capability? And that's kind of sent me into a research of seeing what other binaries there are, and eventually form the concept of BACE, binary that allow you to execute arbitrary code. So if you think about why we got to this position where a command that we did not create or modified an application gave us this privilege, it's either by design, which means that someone wanted that before and that kind of rooted itself within the program, like in find, that was a feature request that somebody implemented. In other cases, as you will see soon in the example, it was a byproduct. It was not something that the original author of the program was designing for, but a way that I managed to exploit or circumstance the situation into running a code. Regardless of these, the source of why it's happening, understanding and finding a base file on a target operation system is the first step to implementing a backdoor with the metadata. This will be a launcher. This will be our springboard to basically execute what we would like to once we would like to activate the backdoor part. The second part is completely different and dissociated with the BACE binaries. Let's talk a little bit about the Unix kernel or the implementation for the impersonation within the Unix operation system. So the problem is that in the beginning, of course, there were the root users and other users needed, simply said, root access to perform certain actions. Now, of course, sharing the password is a bad practice. Having everybody root is a bad practice. There needed to be a mechanism that would allow, even temporarily, for programs to elevate their permission in order to perform a task. And the most obvious example will be the passwd. So anytime that you would like to change your password in a Linux machine, that program will end up writing into the master password file, which is protected and is only allowed for the root administrator to do so. However, the passwd is what is setuid. It has the sticky bit, which allows it to elevate into root in order to perform that task. Anybody can run it, and the program, again, giving that permission, can elevate in order to complete these tasks. So if this process is so well and so fine for normal application, can it then be abused? And the answer is yes. I can take the same mentality, I can take the same nation of thinking, I need to have a binary that needs to escalate, to privilege escalate itself into a root, and I can do it using two simple tools that is already built into almost every Unix operation system. And that's the chmod utility, change mode, which allow me to perform that action from the normal terminal console. And of course, the setuid mechanisms, which is already baked into the kernel, allowing that application at will to become a root whenever needed. And so completing these two parts together is what gives us the possibility of backdooring with the metadata. So without further ado, let's dive into an example. So this first example is based out of the previous demonstration that I showed for find, where nothing has really changed. It's the same computer, it's the same find application. I have not changed the binary, I have not circumcised any evidence. What I did do is basically chmod the file as +s. Basically, I made it now to have the sticky bit, the setuid bit. And now, whenever I run it, it would elevate as the administrator. So the same thing I'm going to show right now. I'm going to, again, change the file first, added the change mode into +x, and then the same example will make me now administrator. Takes a second to update. Yeah. Okay. So same examples as before, but before I'm actually going to run it, now being the root on the computer, let's see, where's the user bin file? Okay, so the only thing that I actually changed in the file is I added these metadata, these flags about what this file is. The file size has remained the same. The MD5 has remained the same. We'll talk about that point further on when we'll investigate the different attack techniques. And now going back into, here. Excellent. The same process, now changing ID into bash, has basically elevated me into become a root on the machine. As you can see, without doing anything special, if I'm just a curious person on the system, nothing has changed in the behavior of the program. It works as expected, and unless I know how to utilize it, no one will suspect it. So let's go back into the presentation and investigate the three methods that we can attack programs to give us this output. Before we do that, let's ask the question that everybody loves to ask: will it scale? And as I mentioned before, I kind of drop a couple of hints here that the technology that I'm using, the concept of setuid, chmod, and these binaries, is not actually limited to Linux or a specific distribution. So I've tested this technique, me and my team, on these following operation systems, and this is by no means the end of it or the limit of it. These are just the things that we've tested. And by the end of the presentation, I would release an Excel spreadsheet with all the different binaries that we have mapped. And it was a huge manual labor to do it because, as you will see, there is no way to search by this in the operation system. It has to be tested manually. But at the end of it, I will release a spreadsheet that you can use to basically check on your operation systems. And of course, it's up on the GitHub, so you can also welcome to contribute into it. But just quickly to go through, so we're talking about Linux, we're talking about BSD, we're talking about Mac, we're talking about Solaris. They are all vulnerable to this logical problem. So let's talk about the actual techniques. The first technique, as we've seen, is what we call the direct command. The direct command is a situation where the binary, similar to the find binary, has a flag that you can invoke during the execution, and that will basically get you into the mode where you can specify to that program what would you like that program to do for you. There are certain side cases, as you will see, that sometimes the program would also pass some kind of a parameters to the program, expecting some kind of an API, and I will show a workaround on how you can mute that noise. In other cases, it can try to force feed some kind of information into the pipe of the program. Again, this could show a problem when you try to use, let's say, Bash or another program that is sensitive to it. I'll show later on how you can make a wrapper that will basically ignore that noise and follow through to the end game, which is giving you the Rootshell. So I've presented, the find example, which is a direct example. Here's another example that I will demonstrate right now. And that's a favorite nice binary called user-bin-env. User-bin-env is used a lot when if you have experience writing shell programs or scripts. It's usually a way to basically find a cross-platform settings of Python or Perl without trying to hardcore the URL, the file path, And in that case, this is a very popular binary. As you can see, changing the binary, elevating it into +s as a root, meaning that once you're an administrator on the machine, you change that file flags, and the next time that you will try to run it with a bash, it will end up into becoming a root shell. So quick demo of this technique. Again, invoking it with my desired command line, made env run bash, elevating it into root privilege, and I've been giving a backdoor into the system. As I mentioned, the art of finding these different binaries is not very trivial because there is really no tagging or there is really no category that you can search for and say, oh, is this binary can do stuff for me? And so it's more of a byproduct of using different keywords that could help you land on programs that may have this capability. And this is just a couple of keywords that we were using during the process of trying to map these different operation systems, find programs that speaks about execution, command, and basically going up from there, hoping that indeed it's something that we can then utilize to have them become a BACE binary. The pros and cons of this technique, which will be fairly simple for all of them, is that the pros, again, we do not change the file size or content. There is no internet connectivity requirement. We're talking about built-in binaries, so nothing to be transferred. The con is obviously changing the flags of the file could be an indication, could be a signal. if the company or the IT department is looking for it. And of course, in the particular method of the direct invocation, it's important to remember that utilities like PS would display the flags. So again, if you're doing something fishy, it may come up during such utilities. Now, you may have probably guessed by this stage right now that the initial idea of elevating a privilege binary is not new at all, and it's actually has been existed at least since the 80s, where I got into the security game. Now, the technique back then was known as the traditional backdoor or Rootshell backdoor, was basically saying take a shell out of the computer, duplicate it into some kind of a secret location, and then change the file permission. And so that worked for many years and still is working for many of the cases. However, there is an obvious anomaly here. Creating a new file, it's a larger indicator, a larger footprint within the system, because we do not know what kind of processes running on that system that may examine that file, new file introduction, or in some cases, thinking about a read-only situation, creating new file is not even allowed by the design of the system. And therefore, what we offer today in the BACE method is that we do not need to create a new file every time. We can change existing files, not all the files. Some files will automatically drop into root, and that will be very obvious for the day-to-day users. But such as the example of the find, nobody will notice anything unless they will be playing with these parameters, and then the anomaly will jump in. So when comparing these two methodologies, obviously there's less cons in the BACE approach. So coming back into the EMV, like I said, it's a very popular binary found in many, many different platforms. And it's actually the first kind of cross-platform BACE that we found. And it's cool because it means that you don't have to think about the CPU architecture or the type of operation system and API. Basically, the same binary exists in all these different operation systems and potentially some more. And every time that you will change its flags, it will behave in that way, and therefore you can have a cross-platform kind of a technique. And we found a couple of more. Given it's a bit rare, we don't have a lot of those, about 6 to 8, but still, it's a nice finding all in all. Let's talk about the second technique. The second technique is involving environment variables. So long time ago, before configuration files were popular, JSON, ENI, XML, in Unix tradition, programs would export some functionality or some configuration based on environment variables. It still is true today for programs as well. And so when we thought about what kind of functionality or configuration that is relevant to our case, we stumbled upon two very obvious ones, the visual and editor. So some programs, like for instance crontab, allow you as part of the functionality to edit a file. Now, of course, there's many opinions about what is the best editor, VI, Emacs, Nano. Let's not get into it. However, given that this is what people expect to change the editor, they have exported this capability to change the editor at will by defining this environment variable. And so we took that notion, we started looking for binaries that are sensitive to visual and editor and see how far we can get with them. And so we found the curious case of VIPW. A VIPW is a utility that allows you to eventually edit the shadow password file on a computer. And so like every good utility that allows you to edit a file, it also accepts the editor environment variable for the preference of the user. However, when we try to run it, we stumble upon a very interesting error. It seems that while we're trying to invoke a command line that involves a binary, a base path, and a command line option, -p for bash, the ViewP program is designed to run it as a sole program without any parameters. And therefore, it's literally trying to search for bin bash space -p, which is obviously not a real file. And so this is the first time that you can start thinking about, well, what will be the right case? So there's a couple of ways that we could have gone from this situation, right? I mean, we could have settled for a shell that, may not need any command line arguments to drop into root privilege. Specifically, bash requires the -p flag. Otherwise, it will ignore the setuid. That could have been one very legitimate way to go about it. But of course, being the stubborn people that we are, we try to find a way to make it work with bash. And that kind of led us into the wrapper solution. As I said before, playing with these programs, trying to piggyback on different mechanisms to inflect them to run arbitrary commands, we end up in this situation where they either try to pass parameters, expect certain parameters, try to force some kind of a data stream upon us. And the way that we've managed to handle all these edge cases is by basically building a small wrapper. So this is a very small wrapper that we've built in C, and the idea here is very simple. What we do is then, instead of trying to run the destination program as is, or whatever we desire to do, we'll simply code it within the wrapper. The wrapper does a very simple task. It accepts the command line options, it accepts the std stream, and simply ignore it. It does not care about any of those parameters, basically isolating our endgame from the running conditions that we have given. All it really does is simply elevates itself, asking the operation system to change the UID, the real ID of the real ID and the effective ID, the EUID and UID, the real and the effective ID of the process to root. 0 signifies root in this API, and then basically goes ahead and run the program, the end game that we have desired. And so if you're looking on this, and I basically run it over here, but if we're looking on what it gave us the piece of quiet. Then now we simply build this little wrapper, we drop it anywhere in the system for the purpose of the elevation. We then use the same command that we used before, and it's going to work. Again, the search for trying to understand how many programs out there can be affected is not very organized. It's, again, going through documentation, hopefully looking for application that using these keywords allow this functionality. By no means it means it's only limited to visual and editor. There might be more of it out there, but these are the ones that we found the most majority of the BCs, the BACE binaries with. And so, what are the pros and cons of this specific technique? Again, the pros, remains the same. No change in the file size of content, which means nothing noticeable immediately. No network connectivity required. Again, the small setuid program should not be downloaded over the internet. It can be typed manually. And the cons are, again, changing the flags, the permission of the file is noticeable. And then if a middleware is required, if we do end up using the setuid, because we end up in a situation where we have one of those problems, then we also would need some kind of a compilation tools on that box. Again, something that you can commonly find today on many of the distributions as is already. And so this brings us to the last technique, and that is spawning a process. So if you think about that, up until now we have exploited application CLI. So we try to attack them on the command line options, as we did to find an env. We've also looked at that from a little bit of the configuration side of the house by trying to attack environment variables that the programs will take into consideration before executing. But what about the program purpose itself? Maybe within the application itself, spawning a process is something that is freely available, and all we need to do is simply ask for it. And so, again, the limitation that we're speaking about here applies to the same technique. We may be spawning a process to an application. During the process, it may try to force feed some kind of parameters. Going back into the setuid wrapper, that will be the right way to handle it. But let's see an example of one of those applications. Now, given the third category, the child process spawning, is very hard to find because, as you can imagine, people don't just write programs that run other programs for the kicks of it. Most of the application try to provide value, and that value is by doing something unique. Running a program is not really a unique feature or something that the user will need to within the Linux environment, assuming you already got a shell to begin with. But if you look on interpreted BACE programming language, and I'm just using here Python because I'm a big Python geek, but it's the same idea could be applied to Perl and Ruby and other interpreted BACE languages. They basically give you a console, and that console you can then go ahead and program it to do different things, right? And one of the things that you can do is that you can pretty please ask that program to run another program. That's a very viable, that's a very logical thing to do. And so in this example again, what we're doing is that we are taking the Python interpreter on that system, and we are adding the setuid bit into it. And then within Python, if you don't know Python, I'll just quickly narrate what's happening. We're importing a model called OS. OS is the Python model. It's a built-in model that basically allows Python to access OS capabilities, obviously running system commands and creating process modification goes through that model. And then the same notion, the same kind of logic as we applied on the actual setuid wrapper, we're asking to elevate the process of the Python, basically asking it to inherit the root administrator capabilities, and then going strictly and asking it to run whatever it is that we'd like to run. And in this case, it's the Rootshell. And the end result is very similar. Again, just from if we're thinking about whether this is a vulnerability in Python or something, the answer is no. This is by design capability that allows Python programs to do different things, and obviously running programs within Python is a legitimate ask. So there is no vulnerability here except an abuse of a situation that ends up into becoming a backdoor. Like I said, it was very, very hard to find that kind of capability because, again, not all the programs are using the same terminology, not all the programs describing it the same way, but Spawn is something that we have found to have at least a couple of results that were interesting enough, for us to dig in. This situation, this situation being more flexible in nature, especially when we're looking on programming languages, it basically reduced the Cont into just a single disadvantage. And that's, of course, the inherited one. We need to change the file flag. But other than that, we control the std in, we control the std out, we control the parameters. We can guarantee there is not going to be any noise. So this technique has the least amount of disadvantages. So as I mentioned before, I have released an Excel, me and my team, that is happily sitting in GitHub. And please feel free to go ahead, download that link, contribute into that Excel spreadsheet. As I mentioned before, we have looked into a number of different platforms trying to kind of scale the problem and see how it reacts in different operation systems, Solaris, BSD, Mac, Linux, and it's still work in progress, right? We've done a lot, but it's by no far the end of it. So if you can help, please help. Let's talk a little bit about the detection and mitigation of this technique, right? So up until now, we were very kind of happy about what we achieved. Let's see how we can defend against that thinking forward. So first and foremost, it's important to know that in the current system, in any current system, the number of setuid or setgid, the G stands for a group, as the U stands for a user, because you can also have tricks where you change to a certain group, and then from there you can maybe use sudo and other techniques. It's also available conceptually backdoor. So you need to know these binaries, right? You can search for these binaries, you can sort them, and if tomorrow you're coming up and you're seeing a new binary, or a binary that you never saw before in that list, most likely this is not a good thing. Most likely you didn't run any kind of an update that produced that, but somebody has backdoored your machine. So first and foremost, know your binaries. The second is check early, check often. Okay, like I said, checking that list on a daily basis, or using programs that can do it in a near-time fashion could help to keep you up to date. And then third is to use utilities, hardening utilities that are basically subverting the power of setuid. So the vanilla approach of the Linux and Unix kernel at large here, right? I keep saying Linux and Unix, but BSD and all the other animals of that kingdom is behaving the same, is that setuid, if you're taking a binary that is owned by the root and has the setuid bit associated with it, it will always accept it. Regardless of why it happened, the kernel won't ask twice. Now, there's utilities out there that you can go ahead and say, I don't care about how many times an application asks to elevate its privilege. There are certain rules that needs to be filled in. And again, you can customize this to as much as your imagination would like to, but you can then again use SE Linux and AppArmor to subvert the default behavior in setuid. And then if somebody even takes and creates this backdoor, it won't work because the setuid won't operate in the same manner that's required to elevate the privilege of that binary. Given it takes a lot of work, a lot of knowledge, but it's definitely worth it. Let's talk a little bit about the future methods. So up until, or what I presented here today, are first degree for BACE, which means that I've shown you how to go from not having a root administrator access on the machine to getting a root shell, which is a very direct and short path. However, like I said, it doesn't really have to be that way. You can be sophisticated and you can find other binaries that has the same kind of type of mentality. So a second degree binaries that we can think of that maybe won't allow us to execute our direct commands directly could be BW binaries that allow us to arbitrarily write data, and then we can use such binaries to add ourselves into a sudo or to other file and use this opportunity to elevate into a root. It could be reading this information that we can then use to our advantage to crack a hash or basically read the password if it's in plain text and elevate our permission. It's not that this concept is limited into only run commands. It can be modified and be pretty complicated and sophisticated. And of course, as with everything good, we can chain these things together. We don't have to be exclusive here. We can have a BW to help us gain root, given that we can write to a file like the password file, and then we can go ahead and become root and then create a BACE on the system, take find or env or other files, turn them into a backdoor. And then we can remove the BW, the first way that we got in. So as you can see, we can play with this, we can composite some fairly complex scenarios. And of course, there's other exotic features that might not end up here on the list, maybe something that can do something that has to do with hardware capabilities. Once the file has been escalated, an application or network, there's also an open idea from here. Like I said, this was a very manual and tiresome process to map all these binaries. I'd like to thank my partner Itai, who helped me doing this process. Again, took many, many hours, and we're proud of it, but acknowledgement needs to be made. And with that being said, I'll go into questions. Any questions? Yes?
So, what method did you do actually to get those stuff? Was this all trial and error, able to be updated, or did you
Yes.
have a certain kind of recipe to figure it out and to do it and wrote a script and then start doing it systematically from through the binary and see what happened?
We tried the first approach. This is the Excel file that is being released. I'll just zoom in a little bit so you can see. We've tried in the beginning to take, let's go to Ubuntu here. Let's zoom in again. We tried to do the first method where we said, well, maybe we can take some kind of binaries and script it around, but as you can see, going through this list, The API, these different programs takes different API, that takes different flags. And of course, we can fuzz it, we can brute force it, but that was not the shortest path to the goal. The shortest path was, like you see over here, when we documented each program as we went through, we looked for it, we read it through the man page, we saw what potentially could be the right flag, and then we applied it. There could be a room for automate the process, definitely. Sadly, we did not find something that can coexist on, again, I'll just go here to the BSD to show a different flavor of commands that we found that, again, has a different type of notation, different type of expectation. It was mainly a manual work. Yeah. Sorry? Can't hear you?
I said, I'm sorry, but the only thing about it, so within the main file, we're looking for a certain key executed by
yeah.
execution.
Yeah, and I mean, this, because it's blown up, right now I only spend the time here, but as you go down in the Excel, the second method, we were looking for editor, and the third method, this is the second, we actually didn't find a third method here, so it was only Python. But yeah, it was mainly going over man pages, looking for keywords, trying to educate ourselves about another keywords that we should be looking for, because we don't know what you don't know. These are just the ones that we stumble upon that kind of made sense to us, and end up being into a collective of these different commands. This is the, just to show, this would be the cross-platform table, as you can see. We couldn't find much, but we could find a couple that are resident through the main page is identical, or the functionality is identical. Like I said, bash, change root, env, find, those the one prevailed through the entire test set that we have created. Funny enough, depending on the operation system, we have found that there's discrepancy that some things would work on 2 platforms, but won't work on a third. Again, depending on the binaries, some operation system sometimes will apply local patches that will change the behavior as well. So we stumble upon that too. Yes? No. That was one of the things that we wanted to get to, but we have not. We did look into Cygwin, but Cygwin did not deliver the setuid part. So it did deliver the conceptual, the binaries, but it didn't allow Windows to elevate the process into administrator or root. I guess the Linux subsystem will be more truthful to its source. It will allow setuid to work as expected. Yes? Sorry, if you can just speak a little bit up.
This information could be really helpful.
Sure. So my thoughts is, and this is not specifically to this research, is that once we do a public disclosure of the information, the good guys and the bad guys now have a level playing field, right? You know this information right now. You can write a script that will monitor these changes. Up until now, if nobody would have said anything, I couldn't say that I'm the first one to discover that. Maybe I was the first one to present about that, but maybe people figured it out years ago, but never got caught. So I think the best way that we can do is do a responsible disclosure, speak about it, and give the good guys a chance to understand this attack. Any more questions? All right. Thank you very much.